Sine of a quadratic expression. Sine of a quadratic expression. Sine of a quadratic expression ax square plus bx plus c depends on various factors. Factor number one, if the roots are complex, then there are different conditions which will basically determine whether ax square plus bx plus c is positive or negative. So if the roots are complex, let the two complex roots be alpha 1 and alpha 2. Whenever I have complex roots for a quadratic expression, one root will be of the form p plus iq, the other root will be of the form p minus iq. Because please understand, one root will be minus b by 2a plus root over b square minus 4ac by 2a, and the other root will be basically minus b by 2a minus this. So if this root over b square minus 4ac is going to give me a negative or an I value where I is equal to root over minus 1, one value will be this expression minus this expression, and the other will be this expression plus this expression. So one is p plus iq and the other is p minus iq. So ax square plus bx plus c can be written in this particular fashion: a into x minus one of the root into x minus the other root. Okay, one root, the other root. That is how we write it, right? Whenever x is equal to p plus iq, this entire expression should be equal to 0. That is what a root means. Root ka matlab hai the value of x for which ax square plus bx plus c is equal to 0. So if x is equal to this, the entire expression is equal to 0. If x is equal to p minus iq, the entire expression is equal to 0. Okay, so this can be written as x minus p minus iq, x minus p plus iq. So this is nothing but a minus b into a plus b is a square minus b square. A minus b into a plus b is a square minus b square, which is equal to a into minus I square will be equal to I is equal to root over minus 1. I square is minus 1. Minus I square will be plus 1. I square is minus 1. Minus I square will be plus 1. This is what we'll have. So this expression will always be positive. This expression is a whole square format, x minus p square plus q square. This is a square format. So if this is a square format multiplied by a. Now, obviously, this entire expression will be positive or negative depending on the value of a, right? If a is positive, the expression, I call it e, will be positive. If a is negative, the expression e will be negative. So that is a very, very powerful result. The result being, if supposing I have f is equal to x square plus x plus 1, you can easily see that in this case, b square minus 4ac is negative. And if I know that b square minus 4ac is negative, the sign of this entire expression will depend on the sign of a. So if a is equal to 1, which is positive, this expression will always be positive. Isn't that a very powerful result? If I know that b square minus 4ac is negative, this expression f will always be positive for all x, because the coefficient of x square, which is a, is positive. So just by knowing the nature of the root and the value of a, which is the coefficient of x square, I can comment on the entire expression being always positive or always negative. Right? Very, very powerful result. Okay. This is the first case when I know that the roots are complex. Second case, roots are real and equal. So when will I have the roots being real and equal for any quadratic equation? It will happen when b square minus 4ac is equal to 0. It is like example being x minus 1 square is equal to 0. Obviously, x is equal to only 1. 1 is the repeated root. Right? So roots being real and equal means b square minus 4ac is equal to 0. And ax square plus bx plus c can be written as x minus, supposing the root is equal to alpha, same repeated root. Correct. So if I have this expression being written in this way, obviously I know that this is equal to 0 for only one value, that is alpha. Okay. So what can be said about the expression this? Now this is always greater than equal to 0. So again, if a is positive, the expression will be positive. A is negative, the expression is negative. That is, depending on the value of a, this expression will either be positive or be negative. Clear hai? Okay with everyone? So roots being real and equal, this is what we have. The different case of roots being real and unequal. Roots being real and unequal. Let the two roots be alpha comma beta. Without loss of generality, let's take that alpha is less than beta. Both the roots are different. So one of the root has to be lower than the other root. That is but obvious, right? So ax square plus bx plus c can be written as x minus alpha into x minus beta. One of the root is alpha and the other root is beta. Now, whenever x is less than alpha or whenever x is greater than beta, x minus alpha into x minus beta will be positive. Hence, if a is positive negative, expression will also be positive negative. So if a is positive, expression positive, a is negative, expression negative, because this part is positive. If x minus alpha into x minus beta is positive and a is also positive, expression positive. X minus alpha into x minus beta positive, a is negative, expression negative. That is what I'm saying here. As simple as that. Second case, x lying between alpha and beta. That will mean x minus alpha into x minus beta will be negative, because x minus alpha will be positive, x minus beta will be negative. A negative positive will make expression positive negative. So if a is negative, expression is positive. If a is positive, expression is negative. So this is the only case in which the expression sign will be converse to the sign of alpha. Otherwise, in all cases, as you saw, अगर a positive है, expression positive है, a negative है, expression negative है. Only in this special case, when x is lying between the two roots, will I have the case where a negative expression positive, a positive expression negative. right? So this is about the sign of a quadratic expression. ठीक है, ये बहुत ज्यादा जरूरी है, especially in the problems where you are told to find out a maxima or a minima, or you are told to find out the number of real roots for an expression. तो वो सब केसेस में ये काम आएगा, डेफिनेटली बहुत काम आएगा. ओके, sure, I'll show you a few instances where this will be used.